So welcome everyone, and thanks for joining us today. I am Alex Bols, Senior Technical Advisor here at CHBA, and my co-host is the legendary Frank Lohman, Senior Director of Building Science. We also have Natasha Rombo with us in the background. Natasha is CHBA's Director of Marketing and Communications, and I can confirm everything would fall apart without her, so thank you for being here. Today we have a 1-hour webinar with lots of new information to share with you. Today's webinar is the second installment in our brand new early adopter webinar series. Today's early adopter will bring us on his journey on how his team learned what it takes to go beyond code minimum and to improve the suite acoustics and limit sound transmission in his projects. Before we dive into that, we have some housekeeping to do. The recording of today's webinar will be available on the CHBA website to CHBA members, usually within a day or two, in case you can't stay to the end or want to watch the webinar again. We also are posting the PDF document of the slide deck on CHBA's member website. I also wanted to let you know that we've muted all participants. It's nothing personal. We just do this for all of our tech webinars. We are trying, however, to make the webinar as interactive as possible. That means you could ask questions throughout by writing them in the question and answer panel by clicking on the Q&A button at the bottom of your Zoom window. We may answer some of your questions live during the webinar or by responding directly to you in the Q&A panel. As in other technical webinars, we will have a few polls for you. So let's cue poll number one, Frank or Natasha. Let's try our first poll here. Should see a pop-up window. We want to know the primary region where you and your business or organization operates. This question helps our speakers to know where you're all coming from. Sometimes this gives us insight where a topic is more relevant in a particular region. Got a lot of people coming from BC, Ontario, some nice diversity, Alberta, some Saskatchewan, Manitoba. Fantastic. That's great. Fantastic. Okay, so let's explain what this webinar series is all about. The idea behind the early adopter webinar series is to showcase innovative solutions, emerging technologies, or technical solutions that address upcoming code requirements or demonstrate how they exceed minimum code. The format is that we have a builder or renovator provide their real-life commentary after an expert co-presenter has explained the new technology. The early adopter has voluntarily adopted the new technology, practice, or innovative idea and shares what worked and what didn't work by showcasing their project and their journey. We hope this concept will help other builders and renovators to get a head start on cost-effectively incorporating best practices into their projects. As you can see on the slide, we had integrating resilience. That was our first webinar of the early adopter series. It was a great success, and we are considering having future webinars on resilience that will take a deeper dive into specific climate hazards separately. Today, of course, we have the effective techniques for limiting sound transmissions. And finally, we do have something planned for the fall. I will share that it's going to be on mass timber. We think our friends from the Canadian Wood Council will be the technical expert, and we have this fantastic builder from BC who's going to join us, so stay tuned. I also want to mention that we have ideas that will easily take us into 2027 and beyond, so stay tuned. The series is open-ended, and if you have ideas or suggestions for a topic, please let us know. With that, we hope that all groups and professions in our membership find this equally helpful. So let's find out who is represented in today's audience and run poll question number 2. What best describes your discipline or profession? This will give us an idea of what professional categories are represented in today's webinar. A lot of developers is fantastic. Renovators are coming through, site builders, some modular builders, EAs, some architects. Fantastic. Really, really great diversity today. That's fantastic. And before I present our guests today, I want Frank to provide some context on why this topic is so important. And Frank, someone in the office told me that you're actually DJing and have a soundproof recording studio in your house. Is this true?
No, yeah, no DJing or studio. But I did soundproof all walls and ceilings when we renovated our first floor. And so while we were installing all the sound insulating bats and had all walls and ceilings open, my neighbor came in and called my name. And I saw him, but I could barely hear his voice. And so for a day or two, we were enjoying this huge sound absorber with the kids. And it was so from experience, I know that sound absorption works. It's pretty cool. But I would like to just say a few words. So that's obviously not why we made this a webinar. But I would like to just say a few words on why we chose this topic as an early adopter webinar. First of all, it was part of a list of subjects that CHBA members suggested during our home building week in Victoria, but there are also reasons why people want to know more about it. Canada is moving from a single family home construction to more multi-unit housing, if you want to say it that way. We're building more missing middle housing from duplexes to fourplexes, sixplexes, and even adding secondary suites becoming a lot more common. So that means we're moving closer together and we'll hear each other's noises more. So if we want to address Canada's housing supply crisis, we have to build these multi-units and more secondary dwelling units. And secondary suites in particular was a reason we wanted to bring this to your attention because they have a function in making housing affordable, because they allow home buyers and new homeowners to rent out the suite and help finance their mortgage. And so what we thought is when markets shift like this from single family housing to multi-units, sometimes this opens opportunities. And we think good acoustics in multi-unit construction and or even for a secondary suite is one of those opportunities. And as we're all moving closer together, sound transmission between these units becomes more important. When I did my first work term at the Acoustics Lab at NRC in Ottawa, my supervisor explained to me in a strong Scottish accent, the student from Germany at the time, that in Canada we deal with acoustics by distance. We just build the houses further away from each other. So that was even then in the 90s the logic. Well, that doesn't work anymore, especially not in a multi-unit environment. And it's now clear that Canada's sound requirements in the codes are also very low. I recall seeing an international comparison a few years ago where Canada's code requirements for sound transmissions were ranked 40th, I think, worldwide. So this is manifested by complaints that are received by city bylaw offices and even in cities review requests for new builds and condos and commissioning files. So even though the national building codes were updated in 2010, the method of demonstrating compliance was changed from STC to ASTC, and Andrew will talk about that. But the level of performance was not increased, and it has not changed since the 90s. So the code has some great information in it. In the sound and fire tables, you can find a lot of assemblies that look like they produce good sound transmission. But as many designers and builders may tell you, especially Andrew and Neil today and Sal, just building the dividing wall well does not do much. So this is where innovation comes in, integrating better sound transmission solutions up front in your design, using details and materials that exceed code without cost increases can set you apart in a crowded, difficult market. And it's not about spending more, it's about knowing how to do it right and smarter. We're hoping that by the end of today's webinar, you'll have the tools to be an early adopter, to offer quieter, higher quality units, and to market your project as better built rather than just code compliant when it comes to noise protection. And of course, to avoid costly callbacks and complaints from your clients. So once you've heard the specifics from today's speakers, you will pass code with flying colors and be able to create great spaces for your customers without more cost. With that, I'll pass it back to Alex to introduce the speakers.
That was very well said, Frank, as always. And it's a perfect segue to introduce our guest presenters and early adopter. CHBA is very happy to have Andrew Brassington, Sal Ciarlo, and Neil Hawkins with us today. Each of them bring a wealth of knowledge. On behalf of CHBA, I'd like to thank each of you for taking time out of your busy schedule. Today's topic is improving suite acoustics, effective techniques for limiting sound transmission. We'll start with a presentation from Andrew. He's going to take us to school and introduce the fundamentals of acoustics. Andrew is the technical sales manager for Owens Corning in Western Canada and has over 2 decades of experience in the building construction manufacturing industry. Previously, Andrew has held key roles at leading manufacturers, consistently driving innovation and performance. He holds a position on the National Board of Directors for Construction Specification Canada and contributes to the Technical Committee for the Canadian Home Builders Association's Net Zero Council and Build Edmonton Metro. Andrew regularly shares his knowledge with architecture firms, contractors, and builders on critical building envelope topics such as waterproofing, air barriers, and insulation. His insight and experience make him a trusted resource within the building design community. Also from Owens Corning, we have Sal Ciarlo. I've tasked Sal with providing with insight, some color commentary throughout, so no pressure, Sal. Sal is the Technical Solutions and Market Development Director at Owens Corning Canada, a civil engineer with more than 31 years of experience. He's not old, he's just wise. We were just talking about this. Um, Sal specializes in high performance and net zero building envelope designs, acoustic and fire separation systems. Sal sits on several home builders associations across Canada and is a member and proud sponsor of the CHBA Net Zero Council. Sal has presented educational seminars to builders, installation contractors, architects, and engineers across the country, focusing on high performance building envelopes and the importance of envelope first to ensure durability, comfort, and resiliency in houses and buildings. After Andrew's presentation, we'll hear from our early adopter, Neil Hawkins. With a home building career spanning 30 years, Neil Hawkins brings a depth of experience and understanding of home building with him. The past 14 years with Avalon Master Builder have been a journey of industry-leading innovation and drive toward energy-efficient homes with the goal of building net zero at no additional cost to the customer. In his current role as development manager, Neil continues to lead the team of consultants, contractors, and staff towards achieving Avalon's mission to build great homes. So, while Andrew, I'm going to cue you up to take over the screen here. Natasha, can you please run poll number 3? I thought this was good for our speakers, the audience, and CHPA to understand. We'd like to know where everyone is on the journey towards high quality suite acoustics. Do you follow base code or do you go beyond minimum code? There's a really good variety here. That's fantastic. That's excellent.
Perfect. Andrew, we see your slides. We just don't hear you. You're still on mute.
There we go. Oh man, we're still having challenges with that mute button. I can't believe that. Thank you so much for that fantastic intro, Alex. I appreciate it. So, thank you everybody for joining us today. Welcome to the Principles of Acoustics. Like Alex said, my name is Andrew Brassington, the Technical Sales Manager for Western Canada with Owens Corning. Uh, The Owens Corning Building Science team consists of Joe, who takes care of Ontario and Atlantic Canada, and Sal, who is mentioned, is also on the on the panel today. He takes care of Quebec and is also the technical director. So Owens Corning is a residential and commercial building leader committed to building a sustainable future through material innovation. In Canada, we have pink fiberglass, we have pink XPS, and we have mineral wool. It's got the highest recycled content in the industry, but it's not pink. We also make high quality shingles, and maybe with a little coaxing, we can make those pink. But utilizing these products, you can build a very resilient home. What we are referring to is Comfort Shield Residential. So about today, here's the agenda we're going to be looking at. We're going to talk about some basic sound terminology. What is sound, followed by how sound transmission travels, airborne, impact, and flanking, those 3 paths. Then, there's always that question. We got great acoustics, but what about fire? So we're going to give you some information in regards to the fire conversation revolving around acoustics. And then I'll leave you with some key resources at the end of this presentation so that they'll help you with your design questions and help you launch into the future. So let's talk about basic sound terminology. What is sound? I always try to lead with a question. If a tree fell in the forest, would you hear it? No, I'm not going to answer that question today. However, I can tell you that sound is generated from a disturbance in air. It's kind of like actually a pebble dropping in the water, and you see all those little waves bounce off. That's the same way sound is. That's why when you're further away, it takes longer for you to get the sound. Sound is made up of 2 components: frequency, which determines the pitch. Human hearing's between 20 hertz and 20,000 hertz. We don't know what alien hearing's at, but I'm sure we're testing right now, so we'll find that range soon. Then we have loudness, and that determines the perceived volume, and that's measured in decibels on a Pascal scale. Now, you might hear decibels and you might hear STC in the market, so I want to make sure you know the difference between both of them. Decibels measure how loud a sound is, so they can range anywhere from the sound that your refrigerator makes all the way to the sound that a hockey team makes or a hockey arena makes when the team's actually winning. And then we have sound transmission class, which is how you attenuate airborne sound. So the higher the STC rating or the sound transmission class rating, the better mitigation of sound, whereas the higher the decibels, that means the louder the sound is going to be. Now, the key takeaway from this particular slide is to show that 0 to 3 decibel changes is barely perceivable. But when you get into 3 STC point changes, that is very perceivable. Or is perceivable. So make sure not to confuse the two, because one STC point is not really going to move the needle. That's going to be barely perceivable, but 3 will be perceivable. Okay, now that we understand the basic sound terminology like STC and those acronyms, let's talk about how sound travels. Well, sound has 3 different ways to travel. Sound can travel through airborne noise, like that, through the wall. Sound can travel through impact noise, so like knocking from dress shoes, high heels, those type of things, kids smashing toys on the floor, etc. And then it also can have a non-directional flanking path, right? And that's basically through all the joints. Any areas where it's not airtight, any areas where it's not sealed correctly, that's where sound is going to pass through. Almost the same way heat would pass through. So let's look at an airborne assembly. So how sound travels through this separating assembly. So we got our noisy neighbor playing their rock music. I don't know why I always divert to rock music. Rock music's great, maybe, but they're playing loud music, and it hits the wall and it starts to vibrate through the studs, and then it builds up in the cavity. So if you have no cavity insulation at all in there, then you're going to get a lot of noise passing through, because as soon as that builds up enough, it goes out, and this results in sound transmission. So what do we got to do? We need to look at the 4 principles of noise control in order to stop this sound from transferring through. So what are those 4 principles? Couldn't think of a clever acronym, but I go with BIBA. So it's break, isolate, block, and absorb. Okay, those are the 4 principles. So we're going to go through each one of them. And believe it or not, a lot of other people have thought about this as something that we should research. So the NRC put together a report with some key people in the industry, including Owens Corning, and they did this report so that they could determine the impact of acoustics with the type of structure and spacing when it comes to wood and steel, with the impact of resilient channel, with gypsum thickness and the impact of additional layers. Is that going to help? And as well as the type of acoustic insulation, fiberglass, mineral wool. There's a lot of different types out there. Every insulation does have its place, but today we're going to talk more about the fiberglass and mineral wool products, because that's something that we represent. So if we look at the B in BIBA, we look at breaking sound or decoupling, we look at the resilient channel. Now, you can see that without resilient channel, we get an STC rating of 42, but with resilient channel, it adds about +7 to this particular assembly. So we can see that there's an impact when adding a resilient channel. It helps break the sound or separate it so that there's not as much of a path for the sound to pass through. Then we look at isolating sound through air tightness. So as this video runs, you're going to see a detail. So that could be house wrap, that could be poly, but it's important to keep your rooms airtight, because when you seal them correctly, that means there's less chance for sound to pass through. We have a chart, which is not on the slide today, that shows that if it's 1/100th of a percent of the wall has a crack in it, that can potentially ruin or lower the mitigation of decibels from 50 to 39 decibels. Now I'm saying decibels, not STC, but if you remember what I was showing you and how decibels work, if you have a reduction in 10 or an increase in 10 decibels, that's like doubling the loudness of the sound. So you don't want that reduction. Or you want the reduction, you don't want that increase. Sorry. Okay, and then now when it comes to mass, we look at mass. So this is the block piece. We did the B, we did the B and the I. Now we're gonna look at the block, or B, that other B. So you can see adding mass. So if we add another layer of drywall on one side, it makes an unbalanced wall, but it adds +4 to the acoustics of the wall. Then we add another layer on the other side to balance out the wall. It adds +8 in total. So 4 on each side. So you can see adding an extra layer of drywall, potentially adding +4 to the assembly. So excuse me, so it does help. Now to the main event, cavity insulation. So does that have an impact on the assembly? You better believe it does. So you can see in this assembly right here, without cavity insulation, we're STC 42, but with cavity insulation, we are +7 at STC 49. So we can see there's definitely an impact. So now we ask the question, glass fiber or mineral wool? So before I move forward, it all depends on what you're designing for. When it comes to different performance metrics, you always have to look at that to make sure you're choosing the right product for the right application. But believe it or not, you're not the only ones that have asked that question too. Because again, we see another report done by the NRC with another consortium of groups of people, including Owens Corning, to show different performances in different assemblies for mineral wool versus fiberglass. And we can see in this particular one, the STC rating is better for glass fiber than it is for mineral by 1 point. And we know that 1 point is pretty marginal. And usually the case, there's usually a 1 point difference between the two in most assemblies. If you're curious about looking at these assemblies more, this particular one is 2 layers of 5/8 drywall on each side, 24-inch on center, steel studs that have a 3 5/8 cavity. And the cavity either has 3 inches of mineral wool in it or 3.5 inches of fiberglass in it. And this is the performance you can get. The transmission loss curve numbers are also at the bottom of the chart. So, and because of that, those tests and other tests like that, this is where we come to the building code. Now, this is where you're going to find all your assemblies in table 9.10.3.1. A is for walls and B is for floors. So if we look at these tables, and you'll see almost on every assembly that requires thick absorbent material, they say footnote 6, which is sound absorbent material includes fiber processed from rock, slag, glass, and cellulose fiber. It must fill at least 90% of the cavity thickness for the wall to achieve the listed STC value, which is right here. So you can see all these products, based on what the building code says and based on testing that's been done, can achieve these values and these fire ratings if it is done correctly. Then we also have the floor resistant table, and it has the same thing, but it's footnote 5, and you can find that footnote at the top of the table in all the headings. So you can see again, sound absorbed material includes fiber processed from rock, slag, glass, and loose fill or spray applied cellulose. So you can see you've got options when it comes to acoustics and fire in wall assemblies. So now let's talk about non-directional sound. So there's 2 ways you can look at it, depending on where you design, whether you have horizontal rooms or vertical rooms. If you have a horizontal room, the flanking surface is going to be the floor, the ceiling, the corridor, or the facade walls. If you have a vertical room, it can be 2 side walls, the facade wall, or the corridor wall. So now you might be asking me, is like, why is this important? Why is flanking important? Well, I'm going to tell you. Take a look at this wall right here. So we can see this wall. We think we've done a great job. We've put 2 layers of drywall on one side, resilient channel, another layer of drywall, STC 52. That's a quiet wall, right? We got good performance there. But then when we do a test for ASTC, we realize we're at ASTC 42. Spoiler alert for everybody on the call, the code requires you to be at ASTC 47. So this is not going to do. So what do? Well, you might have heard the Owens Corning guy talking. He said, well, mass is a thing to help with acoustics. Let's do that. So we decided we're going to add an extra layer of drywall in there. And we're like, all right, we just increased our STC of that wall to 57. So that's great for airborne noise. But that's not necessarily great for flanking noise. So we take a look at this, and then we start to realize, oh, it only increased the ASTC by 1 point. Guess we're not detailing it correctly. And that's why it's important to look at where the problem area is, look at what you're trying to mitigate before just adding materials, find out and make a plan. So we made a plan instead. We decided that we need some resilient layers, some floor topping. That is going to be what's going to help us. So we install these items in there, bang, plus 14. And I'm not going to say the floor mat did it or the topping, but it's a combination of these materials that's allowed it to increase now to a 56. So you can see it gets an improvement, and that's important now to address flanking noise. So like I mentioned before in my spoiler, ASTC 47 is the requirement for NBC 2020. And just so you guys know, ASTC stands for Apparent Sound Transmission Class. So it applies to both Part 3 and Part 9. So that's commercial and residential. For all you commercial guys out there in Part 3, building section 5.8 and A 5.8 has more information for you. And for your residential guys, Part 9 buildings, section 9.11 and A 911. Now there's 3 ways to demonstrate compliance for this. There's one where you can do a field measurement, but you're going to do it when your room is complete. And that's always kind of a tough one, because should you not make this, then you're ripping out floors and it gets pretty destructive. So it's best probably not to look to that one as your first choice. The other one they have on the bottom, the design procedure, well, you can do a lot of walls, but you need a lab. So if you have a lab available, then that's going to work too. But if you don't have either one of those and you want something that's going to do a pass or fail, then we look at the prescriptive method, because frankly, it's easy to use. Let me show you how it works. So with the prescriptive procedure, it's no ASTC value, it's just a pass or fail. You'll get a separating assembly from the table I originally showed you, table 91031A or B, because they have the walls and the floors in there in the building code. Must be above 50 STC. And then you get a joining construction based on the tables that are in A 911 1 A, B, and C, and D. Now I know you're like, that's a lot of letters. Well, that's because it's for vertical and for horizontal. And the prescriptive method keeps everything simple. Here's an example of a solution that would be in there. You have your STC wall that is 50. Then you have your junction point from table 9.11.1.4. And then you have your floor chopper or floor treatment. Now it's going to have a weight. There's also a table in 9.11.1.4 that shows the different weights of floor surfaces, so that you can know which one you need, because it usually specifies whether it's got to be less than 8 kilograms, between 8 and 16 kilograms, and so on up to about 32. So you'll have some information there as well too. A lot of good stuff in that. So if you want a guide that's going to help you perform as well too, we have this guide of calculating sound transmission in buildings. So you can see it's an important thing, and it's something that's being addressed. We've been doing it for a while. This is the 6th edition. Sal is one of the steering committee members of this document, so he's been helping out throughout its path through testing. So I'm going to show you a few pages in there. So take a look at this. This is a double studded wall, because I've seen a lot more double studded walls in construction. And then when you take a look at this, and you can see they have 2 cases. They have case A and they have case B in this. Actually, I'm going to back up a little bit. At the top of this, you're going to see example 4.2.8. Now in this guide, they have examples that start at 4.2.1 and they go all the way up of different types of assemblies. I'm going to show you the summary chart shortly. But with that, this always shows you ways to improve your assemblies. So for example, this says 4.2.8. This is the assembly with the double wall. It shows what's been done and has insulation in the cavity. It can show that what we know, ASTC 47 is the code. Well, if it's a continuous and the board goes underneath the wall, well, they're not going to pass. They're getting ASTC 46. But if it's discontinuous, they can use this assembly, and it's fine, and they're at 56. So what do? The next example that they put out is right here. So then now they add a floor topper of concrete, 38 mils, and then now that brings the ASTC up to 55. So now this wall is acceptable, and it's a passable assembly. They have a table in there. It's called table 4.1, and it shows examples and summaries of the work that's being done. You can see horizontal, vertical. It throws that all in. I'm focusing on double row walls right now, and it shows if it's parallel or perpendicular. It's also going to show whether it's non-load bearing. So keep track of the notes, but it shows different ways to hit those values so that you can achieve that ASTC 47 or higher. And if you like guides and love reading guides, the NRC's done a great job of putting guides through for concrete block, concrete CLTs, wood frame, steel frame. They've done it all. So now I know some of you on the call are probably thinking, hey, it'd be amazing if they put this all in a website, took all those guides and just put them in a website. Well, it's like they read your mind. So there is a website called SoundPath by the NRC. Now, SoundPath is a free software administrated by the NRC. The website is right there if you guys want to check it out. And they have examples from cast in place concrete, masonry walls, all the other guides that I talked about. They put it all in there. So let me walk you through a quick example of how this website works. So you're going to go ahead and you're going to click your chosen or preferred language. It's going to ask you to agree to the licensing agreement. And once you've done that, you're going to be taken to this screen, right? Scroll down to the bottom and select your room orientation, whether it be vertical or horizontal. Adjust the room dimensions to fit the dimensions that you have in the room that you're looking at. And then you can pick the type of construction that you're using, wood frame, steel side, etc. You pick that. And once you've picked that, you can hit next. And when you hit next, it'll bring a calculation based on the parameters that you put in there. So now you got your information for all the walls, all your separating your walls and your total ASTC for your assembly. So maybe you're like, well, I want to look at that separating floor a little closer. So you click on separating floor, and then it'll take you specifically to that detail. And in that detail, see, it shows your separating floor. It has a picture of the separating section, and then it starts to go through all the details and information that's on there. So something to pass to your subcontractor, if you have a subcontractor doing your work, so that they know what they're supposed to have in there, or to an inspector, so that they know that you've passed, and you can say, look, here's the detail right here. And if you want to tweak and play around with this thing to make sure that you can get a higher value, you can start playing around with different assemblies. And once you've satisfied that curiosity and you've got everything that you need, you go to results, and then it'll have all the results for you. Now, if you really like this and you find that you're using it more often than not, you can save the scenario. And if you save that scenario, you can load it back up at the beginning. I'll go back a sec so you can see that. So right at the beginning, you can just load that scenario right away to get it started, so that you don't have to do all the extra work playing around with the different metrics. So once you've done that, you can save or load. But if you want to, you can also generate a report of all this, and this will have a better detail of what you are proposing and what you're doing. So then you can see every single layer, and it really breaks it down for you what you have, so that you have that backup piece should the inspector questioning your design, or should you need the contractor to know a little bit more. Okay, now let's talk about impact sound and how that travels. So impact causes, it happens when both sides or one side gets a lot of vibration. Now they want the recommendation by the code is to have IIC 50, and that stands for Insulation Impact Class. So they want that to be on 55, right? It's not as easy as it's said and done, but it's what they recommend. It's not code though. I just want to make sure that's perfectly clear. It's a recommendation. Now there's different ways to mitigate impact noise. You can use resilient underlayments, like a format, like we have a quiet zone format, something like that. You can isolate by doing you can use isolation pads with doing like a floating floor, ceiling treatments. But the key thing, if you want to see what each assembly looks like from an IIC perspective, that's the other column in the floor assemblies in that table 9.10.3.1b. Okay. Now, here's the question. What about fire? We know a lot about acoustics now. We've got the basic principles. We know the direction sound's traveling, and we've now been able to design a solid acoustical wall, but fire is also a consideration too, right? We gotta take that. A lot of materials that are in non-combustible assembly, especially when it comes to fibrous insulation, have to pass CAN ULC S102 and CAN ULC S114. You probably see this on technical documents. If you're reading a spec, they're probably in there as well. It deals with surface burning and combustibility. So you can see mineral wool and fiberglass both have zero smoke development, zero flame spread, and are both considered non-combustible, right? If you're uncertain whether a material is non-combustible, you can actually, or qualifies as, say, a UL listed product, you can go to UL Product IQ, type in either the manufacturer or the product or the fire rated assembly that you're looking at, and they should be able to provide that information for you. And you can see with the UL Fire Resistance Guide, they say the same thing that the building code says. Well, pretty close. It's listed and labeled material fiber that for building insulation processed by rock, slag, or glass can be used in ULC non-load bearing wall assemblies not exceeding 2 hours when illustrated without insulation, and they will not detract from the fire rating. So that's a key thing. Adding the insulation in is not going to impact or not going to hurt the fire rating. So let's take a quick look at this example right here. So this is a ULC rated assembly, non-load bearing, 2.5 inches steel studs, 2 layers of drywall on each side, 24-inch on center. This is a 2-hour fire rated wall. So if we decide to add some insulation in there, fill the cavity, it's STC 51 now. So we just added 9 points right there, adding insulation without detracting from the fire rating. We can make it bigger. We could go to 3 5/8 and it goes to 55, STC 55. We can even make it even bigger and go to 5 5/8 and it's STC 59. So you can see that it's still, at the end of everything, still does not detract from the 2-hour rating, but now we've got better occupancy comfort because of that, because of the insulation. And home stretch, key resources. So like I mentioned before, we got Sound Pass, we got the guide calculating airborne sound transmission in buildings, ULC's product IQ. I didn't put the picture on there, but that is another resource to help keeping your, or making your suite sweeter, if you see that up there. And then Owens Corning themselves, we have a technical library that you can search all our products as you need them. You can also check out our acoustic calculator as well too. It looks like this, and we took a page, I guess, out of NRC, took our guide, put it into this calculator. So any sort of assemblies that you might want to look at, they are available in there. We haven't got to mineral yet. I know it's something we're working on, and eventually we'll get there. But right now it just has fiberglass in it. A new tool that we also brought out, if you're interested in looking at the embodied carbon piece, because that is coming down the pipe. This calculator helps you calculate a little bit on the embodied carbon as well as potential savings, because I know that's important as well too. We have a guide where you can type in the city and the square footage, and then it'll give you information comparing bags and embodied carbon, as well as comparing cost savings as well too. And the last thing that I want to leave you with as well, this is also available if you go into our Quiet Zone product section of our website. This is where this calculator resides, just so you know. And then finally, I'll leave you with this. We have a competition going on, starts October 6th, Comfort Shield Challenge. Check it out, register for it, chance to win a Vespa, one of 12 of this type of Vespa in the entire, I think, world. So there's only one, and we got one of them. So I think we might have got the only one in Canada. So enter to win. I will drop the link to that in a chat. And thank you for your time.
Thanks, Andrew. That was amazing, amazing overview. While Neil is getting ready, Sal, is there anything as additional commentary or highlights that you wanted to add, or just to bridge while Neil is getting his
And
slides
on
up?
top of that, Frank, I do have a question for Sal, but Sal, it's all yours.
Yeah, no, I think Andrew did a great job in covering in providing the highlights. But a couple of things. If those documents from NRC, those guides are very, very powerful. So Andrew showed on the slide, you've got detailed information. If you're an acoustical engineer and you know how to calculate, you can do that. It's very beneficial. But what I like about those documents is on the left-hand side, it's very pictorial, so you can clearly see the changes and the impacts that they had. So it's very easy to understand, very well done, very detailed, detail oriented, and it's available for different types of structures. So I would really encourage, and those are available. I would encourage everybody to download them, and they're available on the NRC site under archives. So just you can go in, you can download them. They're bilingual. I don't think that the actual document is bilingual, but the introduction and so forth, the explanations, it is available in both languages.
Right.
That's really well said. And Sal, now that we do have you, a question came in. So they're discussing the party wall, and this is obviously out of a wall assembly. And I'm going to put my previous building official hat on. If I show up on site and instead of having that absorptive material in the party wall, the question is alluding to, what if there's spray foam? I mean, as a grumpy building official, I would say, listen, it doesn't meet the wall assembly, but can you answer, can we use open cell spray foam here? Does it compete with the results of BAT? So can you explain why it doesn't or why it may?
Yeah, that's a great question. I saw it in the chat, and thanks for that there. So, from an absorption perspective, because the way insulation or fibrous insulation works is it actually absorbs and it converts that energy into heat. So you need porosity in order for that to happen. So because spray foam, even open cell, is not at the same level of porosity, it's not going to work as much as good as a fibrous material. And if you look in the building code, contrary to what we think that adding density actually makes it better, but you got to be careful because it actually doesn't absorb as much. And if it's too dense, it actually transfers over. And this is why, like for our mineral wool products, we actually sell a product that's half an inch smaller than the cavity because we don't want it to touch because it's denser, so it transfers more. Whereas our fiberglass being less dense, we can make it touch and we want it to touch so it doesn't settle. So you got to think of always go back to the system. The benefits of the spray foam, though, is on the air tightness. That's going to help us because it's going to prevent or help prevent airflow when sound is transferred to airflow. So it does have a benefit from that perspective. May not be as good or as a performance. The performance may not be the same as an absorptive material.
That was very well said, and I could listen to you talk about this stuff all day long. I think Neil is ready and queued up, so let's go to our early adopter. Neil, whenever you're ready. You may
Hi,
be, there you are, sorry.
there we go. Thanks, Alex, and thank you, Andrew, for all that great information. And thanks everyone for coming out today. Avalon Master Builder is a family-owned company in Calgary. We've been in business for more than 40 years. Current ownership is second generation. We specialize in stacked MURB townhome communities. And we are known in Calgary and in Canada, I believe, as a leader in energy efficiency, having completed nearly 200 net zero and net zero ready CHBA labeled homes. We've always been innovators in adopting new technologies. Having some technical difficulties here. Give me a sec. There we go. We have over the years really focused on the energy efficiency piece of things. As was mentioned in the introduction, our long-term goal has been to build net zero homes at no additional charged cost to our customers, and we've achieved that over the last couple of years. It's been very gratifying to get to the point where technology is kind of caught up with our dream, and this townhome here is a rental project, but again, it is a net zero energy townhome that we're very proud of. We consider ourselves industry leaders in building innovation. We have played around with a lot of different building assemblies over the years. We've done combination walls with spray foam and batt insulation. We've built with double wall assemblies. We really try to use resilient materials wherever possible. That includes roofing and particularly siding. Fiber cement and composite wood cladding materials are always our preferred products. Energy efficient mechanical systems as well. We've installed many full electric heat pump systems in Calgary, cold climate, which have worked really, really well. And in our for sale products, we've moved toward more of a hybrid system that gives a little more choice to the consumer as to how they enable that savings. The building I showed you on the previous slide with all of the solar on it is actually a modular constructed project. There are 46 units that were built in Winkler, Manitoba, trucked out to Calgary, assembled on site. And again, that's just sort of an innovation that we're really exploring heavily at this point. we focus on a healthy living environment. It's really important that our customers are comfortable, and we put a lot into sort of extra details on our homes to try and ensure that comfort is there. For the first 10, 11 years of our existence, we really focused on traditional row townhomes. And the building assemblies provided in the building code actually do a pretty good job side to side. This is from table 910.3.1, wall assembly W13A. We've added a few different twists to it from our own perspective. We do add an extra layer of 1/2-inch drywall to each side of the assembly. And we treat our demising walls much the same as you would an exterior wall, as far as how tightly we air seal them. We use a vapor permeable building paper, and we acoustically seal it, top and bottom plates and around all openings, just to keep mainly the air changes down. But as Andrew said, that has a big impact also on sound transmission. So change is good, and necessity is the mother of innovation. In 2011, we kicked off our first stacked townhome community. And these are 3-story stacks, we call them, a 2-story unit above a 1-level unit below. And these are separately titled units. So it's not a basement suite scenario. And one of our challenges when we embarked on this project was really how to manage that perception. It's a noisy neighbors up top, and the lower suites are mostly below grade. We do build them with large front windows and private amenity space, and they're very open, very airy, very comfortable. But selling them can be a challenge when people don't want to be in a basement suite. They do, however, really promote affordable living. So our solution really at the outset was to try and build these with an eye to reducing the sound transmission. This sort of building code standard floor assembly, it would have a 6-inch batt of insulation in it, provides an STC at 54. We went an extra step, and we actually built a drop ceiling below the entire width of the suite, and really suspending it with as little connection to the floor above as we can. So we are using strong backs to essentially support this ceiling below. We had another layer of insulation. And the added benefit of this is you get a nice flat ceiling, and you also have a nice clean place to run all your ductwork, plumbing, electrical, etc. Andrew talked about just the difference between insulating materials. We did use, and this should be mineral wool, apologies. We did initially use mineral wool on the first few projects we did. But after some investigation, came with the same result that Andrew did, that the two products really perform almost identically for this purpose. So as of the last 4 or 5 years, we have been doing this with fiberglass insulation. The other thing that really comes into it in city living is outside noise. We're building more and more density and closer to busy roads. Kind of a happy coincidence again is with our strive for energy efficiency. We insulate the exterior walls of all of our buildings, and just the happy coincidence is how much quieter they are inside. So that is, yeah. This one I kind of pinched from Andrew's slide deck. And this talks about the importance of that airborne noise movement and the importance of air sealing tightly. It's for Avalon's perspective, it really comes down to an energy efficiency, but the side benefit clearly is that we have much quieter homes. That's the end of my presentation, and thank you.
Thanks, Neil. That was great. Alex, if we do have another question, I'm going to grab the screen now. So if we don't have another question, then
Yeah,
I'll
no
continue.
worries. No, there's a great segue. I think I might tap on Sal as well. And we certainly seen this perhaps an ensuite where you have, that bathroom next to that primary bedroom. What type of detail to
Mhm.
improve the acoustic treatment with plumbing stacks inside the wall? Sal, do you have any insight on that?
There's some great documents again at NRC. They've done a great job. Think of that's vibrational energy. So when water is running down those pipes, that vibration is what's going to transfer over. So we have a tendency to think we're just going to wrap that pipe with insulation and it'll help. A little bit. I think what's important is that decoupling. So they cannot touch the structure. So as long as you decouple it, make sure your hole is a little bit bigger so it doesn't touch the floor assembly as that water runs down that chase. That's really the magic. And then seal the opening with something that's soft so it doesn't transfer. Some type of a caulking. If it's required for fire protection, it's got to be a fire block. But that's really the magic. It's that decoupling. If you want to put the insulation, that's good. That's not where I would start.
That's very
Okay.
interesting. Frank, the floor is
Yeah.
yours.
Yes, thanks. Can you just confirm you see my screen there,
We
Alex?
do. Looking
Yes,
looking
my
great.
my screen is all changed. Yeah, so we're running a little later than we wanted. So what I'm going to do now is I'll tell you that the speakers have some more time, so we're going to go to a panel and then a QA so that we can answer some of your questions. We understand that if anyone has to leave at 1:30, if that's 1:30 Eastern, if that's the case, we thank those who have to leave early. We thank you for listening, and keep in mind that you will have access to the recording afterwards. We hope the format and content of today's webinar will have helped you in understanding the fundamentals of acoustics. And if you have to leave and you have any feedback or follow-up, please contact, I guess on the last screen, the emails, which you will then see once the slide deck and the presentation have been uploaded, hopefully by tomorrow. So just wanted to say that if anyone has to leave, so we don't sort of fizzle out. Well, with that, we can now continue a bit of an open end. Let's continue. We do have a panel discussion, but before that, I think we have another poll queued, poll number 4. If Natasha, if you could bring that up. So what we want to know here is now that you've heard what Andrew gave us in terms of an overview of acoustics and heard Neil explain how they went through their journey. With that, would you be ready to be an early adopter and applying best practices for noise protection and sweet acoustics, as Andrew called it? And I do not see how it's developing. So
I'm blown away a little bit. It's like a resounding yes, and then mostly yes, a lot of maybe, and minimal no. So I'm actually floored by this.
oh, I
And
see it
how
now.
dare
Yes.
you use Andrew's sweeter sweets, by the way. I think that's his.
I know. Oh, it's great. I think it's going to stick. So with that, we're going to be on that slide that has been up for a while here. What we want to do is it's a bit of a roundabout panel discussion, and with some questions queued up. And then once we're gone through that, I think Alex, you will have some questions from the audience. So first of all, for all, maybe we'll go Sal, Andrew, and then Neil. What is the single thing that you would tell someone not to ignore when designing for acoustics? And if you keep it short, that'd be great.
Yeah, so thanks for the question. I would say if you heard what Andrew was saying, and from what I've seen and what I've learned throughout my experience with acoustics, is you really got to think of acoustics as a system. There's no silver bullet. There's no one component. The basic principles need to coexist in order for things to work, and it's block, break, separate, and absorb. And I think if we apply those at the right time, and look at the details. They're easy to incorporate, and you'll get tremendous performance. But there's no silver bullet. You basically have to do everything in order for it to work.
Andrew?
Nice. That acronym was better than my BIBA. That could have been SAB. Anyways, but yes. So yeah, I agree with what Sal said too. I mean, if I had to pick one of those 4 principles, I would go with, like I've been talking about, airtightness. The devil's in the details when it comes to this. You could put a lot of cavity insulation, whatever type of insulation you put in there, but if it's not tight and there's room for sound to go around it, then that's where the sound's going to go. So devil's in the details and the airtightness.
Perfect. And Neil?
I think I would go with separation. That's kind of the principle that we went with when we were developing our floor system. We weren't initially air sealing that. It's not deliberately anyways, it was quite tight, but that separation was very important, I think.
Excellent. Thank you. Yeah, especially, I guess, considering that you're building net zero, which is already airtight, but separation, excellent points. Neil, we're going to continue with you. Were there any design changes that surprised you on your journey when you did, as you just explained, the floor system or your stacked housing? Anything that surprised you or your team in terms of the effect on acoustics?
I think the thing that surprises me the most is the exterior, the effect of the exterior insulation. And we built with exterior insulation for a long time, and market conditions sort of pushed us away from that for a few years. And then we recommitted in a big way a couple of years ago to just make this a standard practice for everything we do. And the difference standing inside one of these homes to a well-built home that we built 4 years ago is quite substantial.
Mm-hmm. Excellent. Thank you. Yeah. And the last question before I'll open it for everyone, to Andrew and Sal. Maybe we'll go Andrew first and then Sal. Are there challenges that in working with builders and contractors? Are you finding that there are the same challenges over and over where builders, renovators, contractors struggle with getting suite acoustics right?
Oh yeah, the challenges tend to be a little similar because sometimes it just revolves around 1 or 2 principles. And that's where the focus lies. And sometimes they don't always look at what they're trying to mitigate. It's like, well, I heard this, I'm going to add these components because, I add more insulation because I heard sound insulation is great, or, but not looking at the full detail and realizing they're not trying to, mitigate airborne noise. They're trying to mitigate a flanking detail. So they should be looking at flanking solutions, not adding stuff. So it's just working through those challenges and finding what the actual sound they're mitigating, and then that gets it right. So once they actually start looking at it like that, it usually goes a lot smoother.
Mm-hmm. Sal?
I'm gonna echo that. I think what I have seen is that it's neglecting the details. I think understanding the principles is easy, but when you when you neglect the details and don't do it right, that's where issues happen. I know there was a question in the chat that I saw. So we talked about resilient channels, mechanical decoupling, that it works. But if you fasten the drywall through the L angle and go back into the structure, you've basically negated that effect. If you choose the wrong insulation, the wrong skew, and you don't compensate for the connection by using thinner material when you're using heavier density insulation, then the absorb won't work as well there. So it's really that. It's the difficulty of saying, okay, I get all 4 principles, but then you skim out on the details. You still have to pay attention to those details and install it right. And if you do that, it should be pretty easy.
Mm-hmm. Yeah, great. And so before we go on to the Q's and A's, and again, many people may have to leave us now, but if we will go to the Q and A's. But before we do that, I wanted to ask a question and really ask it to anyone who wants to answer it or has an answer, and that is we've learned about ASTC being the real measure, really, and about high performance. And Neil, you said it really sounds different. Is there a sweet spot? Like you can go as high as you can, of course, with ASTC, and the higher is better. But is there a sweet spot where it's simple enough, cost effective enough, and really good? Would you have an answer of where that sort of space is, the sweet spot of good performance and cost effectiveness or simplicity? And really anyone who wants.
I'll answer from Avalon's perspective. I think that the sweet spot for us on the sound attenuation is really the same as the sweet spot we found on energy efficiency. You know, it has to be affordable. We don't want to break the bank. We want to be able to provide lots of homes for people. But yeah, I mean, there's sort of a diminishing return with adding just more and more into it.
Excellent. Do you guys want to add something, Andrew, Sal?
No, and it also depends on the space, right? I mean, if it's Frank's recording studio, that's it's only his noise, then there is, to me, it's do whatever you want. If it's Merb, go as high as you can because those complaints are real and there could be a greater return on investment. But is there a sweet spot? 55, 60. I mean, that's what Europe is doing. So I'm assuming
Okay.
that they understand it. They've been doing it for longer than we have, and that's what I would aim for, at least a 55 or a 60.
Perfect. Thank you. Andrew, can I leave with that so we get to the Q's and A's or?
Yeah, no, let's go. I was going to echo what Sal said anyway, so yeah, go ahead.
Yeah. Thank you so much. That was a great session. And so with that, I'm assuming you can still see my screen. I'm a little lost. Oh yeah, okay.
Yeah, you're great.
Alex, it's up to you, right? You have some
Yeah,
questions.
I mean, a lot of great stuff coming in. So maybe I'll send this one off to the Owens Corning fellas. Can fire-treated cellulose be used in fire-rated walls? So I'm assuming this is that blown-in product. Sal, Andrew, do you have an answer to that?
Yeah, so any product that is rated as non-combustible to the Canadian standard, CAN CS 114, can be used in a fire-rated assembly. I would strongly recommend. So Andrew showed the tables in the building code that give you the STC and fire-rated performance. There's a series of footnotes there, sometimes as much as 20. There's a reason for those footnotes because it tells you exactly how the products have to be installed in order to meet that level of performance. And so for cellulose, there's specific application requirements. And if you go and you follow those, you should be fine. So it's important to read the details because that's going to guarantee you the performance.
That was well said. And I mean, from my previous experience, definitely if you're unsure, speak to your municipality because you don't want to
Yes.
install this and then have to do something bad about it after. Next question here. I am developing a mixed use building. I have a concrete slab between my residential and retail spaces. However, the slab has mechanical penetrations in it. How do you soundproof these without building an additional soundproof ceiling? Any ideas?
Again, I'm going to go back to NRC. I love what NRC does and all of those documents. They do have a guide on fire penetrations. Uh, I'm not well versed on that as I am on walls and floors, but I'm going to say, hey, it's got to be airtight. You got to seal it up and use those malleable caulkings or sealants, so it doesn't transfer the vibrational energy over. I'm pretty sure that that's kind of what the recommendations are, but there are some good guides that are available again on the NRC archives.
Well said. And I'm going to jump to this one. This commenter says, I believe the NRC studies cited were dated 1993 and 1998. Are there any current ones underway to your knowledge?
So we want to take. I know we had also one guy there from 2023, but I'm not sure about any other studies. Sal, you got thoughts on that?
Yeah, the flanking guides. I don't know if Marcus is here from NRC. I did invite him there, but we work on those guides on a yearly basis. The 2023 is the most recent edition, and we look for collaboration from the industry to build that database every year. So there's going to be more in the pipeline, but there's quite a bit that's out there, and some of them are old because things haven't changed. The science is the science. So
Oh, that's well said. This sounds like this is a builder. I work in a lot of condo buildings. Strata councils have set their own IIC and STC ratings for floor assemblies, and they choose higher and higher numbers, like 74, that no product reaches in proper testing. I guess it's more of a comment, but would you have any, I guess maybe not a rebuttal, but could you comment on this person's comment?
you know, what I heard you say is product, and obviously the performance is not product. It's got to be
Exactly.
system there. Yeah.
Yes.
So you can get to 72, 74. I'm pretty sure that there are assemblies in the guides that get you there. Uh, you know, how how much is too much, I guess is what I'm saying.
I would actually say inform the strata councils that they're barking up the wrong tree. I mean, if you're specing the product, just the wall and just the floor, you're not
Yeah.
understanding what really counts, right? So they should spec an ASTC through those floors or walls because that really is the actual metric that defines what the quality is on the other side.
Yeah, and if you recall on one of Andrew's slides, he had an STC separating wall of I think it was like 55 and double wall, resilient channel,
Yeah,
insulation, and then the ASTC went down by 10 just because of that weak link with the flanking.
exactly.
It's
Yeah.
exactly what Frank just said. If you don't address that weak spot, it's like insulation from an energy perspective, right? If you just fill the cavity with insulation, don't put anything on the outside, that cavity is going to lose R value. That insulation in the cavity is not going to be as effective.
Yeah.
That's very well said. Neil, this one's for you. Has Neil or other builders, to your knowledge, marketed sound attenuation to prospective homebuyers? I would think it would be worth more to most homebuyers than any potential added costs, particularly in multi-residential. So, Neil, are you marketing this added sound attenuation when you're marketing your products?
Yeah, we do. We have for years had graphics of that assembly up in our show homes, and our sales team are pretty effective at bringing that to prospective clients.
That's great. This would probably for the Owens Corning fellas. What would you recommend for floor acoustic assembly if we don't use 1.5 inch concrete topping?
I mean, there's definitely some options. I'll just jump in here. There's definitely some options as far as like resilient layers. It doesn't have to be concrete topper. And if you check in that guide or if you check in the building code, they definitely have a number of other toppings that you can use. And if you don't want to use any toppings at all, yeah, floor mats, like I mentioned a little bit, the quiet zone floor mat that we have, other types of floor mats that are available on the market would definitely help with that impact and some of that flanking noise.
Yeah, that resilient underlayment is what is the key there. So obviously the floating floor gives you a bit of mass. But in one of Andrew's slides, you saw the improvement of just the concrete, adding the concrete layer over top of the structure. And if you go further down in that guide, there's also another example. The next example is what about if I added that layer, concrete topping over top of a resilient mat, and it actually springs up quite a bit there. So as long as you've got that resilient layer, you can build a floating floor like a wood raft to add a bit of mass that would be a substitute to the concrete. That helps. Or you work the floor from the bottom, resilient channels, mechanical decoupling, mass, the detail that Neil presented is a good one. Many options to get the floor up to where you need it to be.
Yeah, double layer OSB. Yeah, there's a couple different, so many different ways. There's a
Very
few
well
different ones.
said. No,
Alex,
that's brilliant. I could listen to you guys talk about this stuff all day long. I can't thank you guys enough. Frank, do you want to have any final words?
I was going to say we're going to call it at 1:45, but there was one question early on. I'm not sure you had it queued up, Alex. That's why I waited. But there was one question. We had a lot of renovators on the call as well. Typically, all these measures, from my view, resilient channels, resilient layers, and so they would be applicable to renovation just as they are to new construction. Can you comment, probably again, Owens Corning more than Neil, unless you guys are doing renovations as well? Is there a key difference in terms of if you have the wall and you can't change the wall itself, is it enough to just do add-ons with additional layers of gypsum board, or can you never overcome some of those, let's say, connections that you have in older walls? Do you have any experience with that, Sal, or?
Yeah, we worked with Canada Mortgage and Housing Corporation a while back, and there was a guide that was actually published. That's I think is still available somewhere in the archives. So to short answer to your question, Frank, is unfortunately, like I said, what's important for this to work, for acoustics to work, is you have to have the four principles. They have to coexist. In renovation, you may not have that opportunity. One of the examples I could say, I often get asked, they say, we listened to you speak. I had a wall. I had a wall with an existing layer of drywall. I put a resilient channel and I doubled up on my drywall. Well, you actually made things worse because you didn't decouple that initial layer
Yeah.
that's actually now amplifying that vibrational energy and it's transferring over. So it doesn't always work, unfortunately, in retrofit. And there may be some trade-offs. There might be a bit of a different thinking, but the common thread is if the four principles coexist, they will always work. It will always work.
Right. Perfect. And I think maybe that's a good roundup and final answer. What we might try is, if you have those links before we post the PDF in the slide deck, maybe we'll put them, or if you can add them to your slides, or somehow we find that, because I think when people download the PDF slides, that may be helpful, especially if we have renovators, and renovation is always a challenge, as we all know. You only know how easy your job is once you start opening the wall. So with that, so we have the email addresses on the screen here. If you have any follow-up questions or suggestions, please use those. As I said earlier, we hope that the format and content of today's webinar has helped everyone in understanding fundamentals of acoustics, noise protection, and create sweet acoustics. I use it again, great expression. All that's left for me now is to remind you that we will post the slide deck and recording hopefully tomorrow, maybe a little later if we wait for that link. And we will have, as Alex pointed out earlier, programming on early adopter series lined up for the fall, but not the final date, so we couldn't show that to you. But it'll be announced in our Housing Tech News or in our normal channels on social media. So with that, again, thank you everyone for listening and staying until now. And with that, I'll release you and have a nice rest of the day. Thank you.
Thanks, everybody.
Thank
Thank
you.
you,
Bye.
everyone.